Hi, this is Charmin here. Today I'm going to teach you AQA GCSE Chemistry Question Paper 2015. So this is a question paper you can download from a website. In my description box you can find a link. You download the question paper and try to do it. If not, then you watch my video and try to write down the answer and practice and do it again and again. That way you can improve your chemistry. So question number 3, this question is about life, the earth and its atmosphere. So there are many theories about how life was formed on earth. Suggest one reason why there are many theories. So it's occurred many years ago, right? It's billions years ago. Yeah. So next question. In this question, you will be assessed on using good English and organizing information clearly and using specialist terms where appropriate. So this earth and its atmosphere today are not like the early earth and its atmosphere. So the early earth, you can see the early earth, most of the surface was covered by volcanoes. So it's too much hot and most of the atmosphere was carbon dioxide and water vapor. And earth today, most of the surface is covered by ocean. So most of the atmosphere is nitrogen and oxygen. So describe and explain how the surface of the earth, early earth and its atmosphere have changed to form the surface of the earth and its atmosphere today. So this is obviously plants or algae that is evolved in the early earth. So they use carbon dioxide for photosynthesis and release oxygen, and therefore carbon dioxide levels go down and oxygen level go up. So cooling occurred, causing condensation of water vapor and producing liquid water, that is ocean. So oxygen increased because plants developed and used carbon dioxide for photosynthesis and growth producing oxygen, and carbon dioxide decreased because of this. So carbon dioxide decreased because oceans formed and dissolved, or you can say absorbed carbon dioxide. So carbon dioxide became locked up in sedimentary. So yeah, and oceans formed because the earth and water vapor cooled and water vapor in the atmosphere condensed, and continents formed because the earth cooled, forming as a supercontinent, and volcanoes reduced because the earth cooled, forming a crust. So yeah, so next question, that is let's see the next one. This is 4 number. All right, so these questions is about metals. Figure 4 shows the metals used to make pylons and the wires of overhead cables, and aluminium and steel. So an ore contains a metal compound. A metal is extracted from its ore in 3 main stages as shown in figure 5. Figure 5, stage 1 mined ore, and stage 2 separated and metal compound, and stage 3 extracted metal. Explain why stage 2 needs to be done. So yeah, and 4b, cast iron from a blast furnace contains 96% iron and 4% carbon. So cast iron is not suitable for the manufacture of pylons. Give one reason why. So you can write here, that is impurities present in the ore need to be removed. Rocks must also be removed. So next one, that is most cast iron is converted into steel as shown in figure 6. So oh sorry, so I didn't give an answer. So cast iron is not suitable for the manufacture of pylon. So give one reason why. So it's a brittle, that is the reason. And next one, most cast iron is converted into steel as shown in figure 6. So figure 6 here, this is, you can see furnace here, steel, oxygen, waste gases, and cast iron. Describe how cast iron is converted into steel. Use figure 6 to help you to answer this question. So you can write here, oxygen will react with the carbon in cast iron and reducing the amount of carbon. So next one, that is 4C. Aluminium and copper are good conductors of electricity. State one property that makes aluminium more suitable than copper for overhead cables. So this is aluminium has a low density. All right, next one. How can you tell that copper is a transition metal and aluminium is not a transition metal from the position of each metal in the periodic table? So you can write here, copper is in the middle block, and that is a transition block, and aluminium is in group 3 of the table, and so is not a transition metal. So yeah. So next question, that is, copper can be extracted from solutions of copper salts by adding iron. Explain why. So you can write here, iron is more reactive than copper and so will displace copper from its salt. So next question, that is, crude oil is a fossil fuel. Describe how crude oil is separated into fractions. So you can write here, crude oil. So crude oil is a fossil fuel. So crude oil is separated by fractional distillation, and crude oil is heated to a vapor and then passed into the column that is at the bottom. The column is hotter at the bottom and cooler at the top. So when a fraction reaches a temperature below its boiling point, it condenses to a liquid and is cooled. So that is, the crude oil is heated and evaporate and columns hotter at the bottom and condense at their boiling point. So this is the main idea. Just write here main thing. No need to details because you don't have much time. Next one, that is fuel oil is one of the fractions from crude oil. Power stations burn fuel oil to generate electricity. The waste gases from the combustion of fuel oil contain carbon dioxide, water vapor, sulfur dioxide, and oxides of nitrogen. So the waste gases are passed through a suspension of limestone in water. Limestone is mainly calcium carbonate. Suggest how the use of a suspension of limestone decreases one of the environmental impacts that the waste gases would cause. So we can write here acidic gases such as sulfur dioxide and nitrogen oxide from acid rain, right? So limestone suspension will give an alkaline solution which will neutralize an acidic gases. So acid rain is caused by sulfur dioxide, we know that, and they react with neutralized by calcium carbonate. And global warming is caused by carbon dioxide. This is the main thing. I'm just explaining you. So let's see next one. Question number 5C. Some fractions from crude oil contain large hydrocarbon molecules. Hydrocarbon molecules such as decane, can be tracked by produce smaller, more useful molecules. Write the correct formula of the third product to complete the chemical equation. You do not need to give the name of this product. So we just write the formula. So you can see that is a decane, that is C10 H22. So pentane, that is C5, and here is a propane, that is C3. So 5 and 3, that is 5, 6, 7, 8. So we need 2. So we just write here C2. And here is 5, that is hydrogen, that is 8. Here is a 10 and 8, 10 and 18. So we just write here H4, that is ethene. But no need to write the product, you just write the formula. Next one, pentane is used to produce polypentane. Complete the equation and the displayed structure of polypentane. So pentane, you can see, just right here pentane. So you just write here, here is a polypentane. So you just make it first. Right here hydrogen here and here and here, and here is a C3H7. All right, and here is an N. So you just draw here one bond here. So yeah, that's it. And let's see next one. So 5C part 3. Some polymers are described as smart polymers. Suggest one property of a smart polymer that is different to that of an ordinary polymer. So that is, smart polymers have shape memory. All right, let's see another question. Oh my god, okay. So question number 6, useful materials includes foods and fuels are produced from plants. Some plants have seeds that contain vegetable oils. Give one reason why vegetable oil are important foods and fuels. So you just write here the reason. Vegetable oil contains energy. That is the easy one. Let's see another one. 6A part 2. State the two main stages used to extract a sample of vegetable oil from seeds. So we need to write here two main stages used to extract a sample of vegetable oil from seeds. So that is crush the seeds and press to obtain liquids. Very easy, right? Okay, next one, that is 6B. One property of a vegetable oil gives the oil an advantage over water for cooling foods. So explain how. So vegetable oils have a higher boiling point than water. Water that is higher temperature can be used, and this allows food to cook faster. That is the reason. All right, next one, and this is the last one, guys. So that is 6C. Vegetable oils and water do not mix. Yes, we know that. An emulsion is made by shaking a vegetable oil and water with an emulsifier as shown in figure 7. So you can see here figure 7 here, vegetable oil and water, and here is an emulsifier and molecules. So you can see this is hydrophobic tail and this is hydrophilic. That is emulsifier molecules and vegetable oil, water, and emulsifier and vegetable oil is up and down. Here is water. Yeah. So explain how the emulsifier molecules are able to produce an emulsion that is a stable mixture containing the vegetable oil and water. Use the diagram of the emulsifier molecule to help you to answer this question. So we need to write here that is emulsifier molecules consist of a hydrophilic head and a hydrophobic tail. The head is attracted to the water and the tail is attracted to the well. So tail is buried inside well forming droplets and the head are attracted to the water and droplets now repel each other and so are consistent throughout the emulsion, sorry guys. So emulsifier molecules have a head and hydrophilic end which dissolves in water. So emulsifier molecules have a tail or hydrophobic end which dissolves in oil. So forms a suspension or droplets of oil in water. So hydrophilic is the head of the molecule or hydrophobic is the tail of the molecule. So yeah, so droplets now repel each other and so are the consistent throughout the emulsion. That's all. Thank you very much. So guys, that's all. Thank you for watching. Don't forget to subscribe and share with your family and friend. If you need more class, go to my website www.advocateshaman.simplesite.com. That's all. Thank you very much.